texture setting and rendering, coloring, rendering camera light sources, and then lastly, we'll do an animation and data output session. So first, let me start off by explaining Forum 8's solutions as a whole. So we offer a family of solutions, and we propose an integrated system of advanced technologies and a top-level solutions from the following 4 aspects, as you can see. So in CG and VR simulation, we have our flagship software you see when Road, as well as Shade3D, which we'll talk about today. We also do FEM, finite element method analysis, using mostly the Engineer Studio software. Also, we do design for BIM, SIM, and CAD, and this also includes a little bit of Shade3D. And lastly, we have a wealth of web cloud services. This offers different types of office accounting software, payroll software, etc. So each of our product line is closely related to each other to develop an even more powerful service, as shown here. And today our focus is this one up here, Shade3D. So what is Shade3D? So Shade3D is an integrated 3D CG production software. And since its release in 1986, the software has been a long seller, selling more than 500,000 units in total. And Shade3D has the power to do modeling, rendering, animation, all the way up to 3D printing, all in this one software package in itself. So Shade3D, what is it used for? So a broad range of applications. For example, presentation of architectural perspectives, product design, space design for events, designing and simulation for large machines, product development by dedicated tool created by internal macro language, creating organic characters, geometries for 3D printing, and many more applications. So Shade3D is often used in the fields of architecture, interior design, and product design. It has a panoramic rendering function, and this supports 3D VR. So you can use for presentations using head-mounted displays. And when you're working in this software, you can edit and nibble on small details, all the way up to large objects and its environments as well. So one good example here is the Le Corbusier chair. So features of Shade3D is apparent in this example. It's a smooth modeling with bright pipes, moist leather texture, and soft shade with multiple light sources on the floor, as you can see here. So these photorealistic rendering results are what Shade3D is known for. We also do animation. So Shade3D has animation capabilities. It allows you to create fly-throughs, walkthroughs, and even character animation like the one up here on the screen. So a simple data workflow of how the everything is generated inside of the software. You first start off with modeling of your project, and then when you are ready with the basic structure, you can move on to edit the materials in the setting materials. Then when overall the actual design of your project is ready, you can change the camera angles to look at how your project looks from different perspectives. And then lastly, you can move to change the lighting, the background, and finally you can do the rendering. As a 3D CAD software, Shade3D has been certified as a recommended software for the first level of the 3D CAD users test, sponsored by the ACSP, also known as Association for the Advancement of Computer Education in Japan. So in general, 3D CAD software is really difficult to present, but Shade3D has a full range of presentation qualities and CG functions. We also support multiple languages, Japanese, English, Chinese, both simplified and traditional. Now, our most recent update is the Shade3D version 22. All our softwares are ever evolving and always updating. So first, I'm going to introduce you to the newest version. And here is a list of the new features: rendering, GPU ray tracing, AI noise reduction, drawing, modeling, and file input-output updates. So I'll talk a little bit mostly on GPU ray tracing and AI noise reduction, but I'll try my best to go through the list. So first, GPU ray tracing, it's a rendering function. So this means ray tracing, which was previously only supported by the CPU, can now be realized by the GPU. For example, a scene like this one, combining reflections, refractions, and global lighting, such as this building, it can be rendered in 2 seconds on a GE4 mid-high level model. I'll show you an actual example later on during the software operation and how it can be done. So until now, GPU rendering has had many limitations and the disadvantages of increased production work hours instead of the advantage of speed. In contrast, GPU ray tracing can simulate various materials and lighting, eliminating the need for work hours for simulated expressions. So now, I'm going to show you a video of it in action. GPU ray tracing can be displayed in the editing screen and can be activated by switching modes. As you can see, glass reflections and image-based driving are reflected in the real-time display. Here is the actual speed on the GE4 RTX 2070, and even large scenes can be tracked with progressive rendering. As you can see in the glass of the building in front of you, the reflections of objects outside the field of view on the curved surface can be seen accurately. Changes to the material settings are immediately reflected, allowing you to simulate the texture in real time. And additionally, it's fully integrated into the editing screen. So you can overlay the wireframe view and enter the editing mode to model while GPU ray tracing is enabled. Reflective and refractive images can also be quickly adjusted and examined. GPU ray tracing can be used not only for previewing, but also for final rendering of still images and animations. Although it requires a newer GPU, it's a feature that can greatly speed up the process from adjustments to final rendering. So next is AI noise reduction. So this is another new feature. So first, let me start off by explaining the problem of conventional rendering. In texture and lighting simulation, the common and reliable Monte Carlo method generates high-frequency noise, as shown here on the left, and various methods have been used to make noise-free images. The simplest way to improve the quality of an image is to increase the amount of calculation, but this is very time-consuming. So for this reason, a number of speed-up techniques have been devised. However, as you can see in the red frame here, there are some drawbacks, such as the need to adjust a large number of settings according to the scene, which requires a lot more work hours. And in contrast, with AI noise reduction, which is a deep learning method based on AI technology, all you have to do is turn on the setting items and functions, and the AI will automatically determine the noise removal. So here's the results of AI denoising using this method. And although this is a scene structure that iRadiant cache is not very good at, we were able to reduce the rendering time by almost 90% using AI denoising. Next, a little more on other updates. This is a CAD-related enhancement. It's the drawing display mode. This is a new display mode that allows you to draw line types, hatching, and other expressions used in general drafting. In the drawing mode, you can give the drawing a readable decoration by setting it in the drawing palette. So you can see the different options here. And line and surface drawing settings for each model from the drawing palette. And in the drawing display mode, it can be also used to create design drawings from 3D models and 3D cross-sectional views like these ones over here. Another new display mode next is, in addition to showing all the lines and clearing hidden lines, we have added a hidden line display mode to the wireframe display, which shows invisible lines as dashed lines. This mode can also be combined with shading and texture display to help you grasp the three-dimensional shape. Um, 2D and 3D drawings created using these functions can now be saved as image files with specified paper size, resolution, and scale. And then finally, it can also be printed on a printer. Next is the sweeping surface. It's a new feature in modeling. So sweep surface is a new shape type, and the shape is generated by placing linear shapes or circles as cross sections or reference lines on the sweep surface part. Unlike existing tools, it's characterized by its ease of post-editing, allowing you to efficiently respond to specification changes and create variations, such as rebar and pipe diameters, rail paths, and baseboard designs. We have also added a new function for freeform surfaces. In the past, closing the edge of a freeform surface required a lot of work. And when the number of freeform surfaces increased, it took a considerable amount of work hours. We now added the close edge to the settings, so you can now generate a face with a single operation, and it will follow your re-edits. There are just a few of the minor, these are just a few of the minor enhancements that will help reduce work hours for you. And next, for file input and output, so first of all, DXF input has been enhanced. Spline shapes can now be imported as NORBs. Colors are reflected in the drawing display mode, and the layer structure has been improved. For the FBX input, the latest format, FBX 2020, is now supported. As a result, it's now possible to import FBX files from the Ministry of Land, Infrastructure, Transportation, and Tourism's Plateau, which is a Japanese open source map data. It includes layout of city buildings and textures assigned to some areas, as shown here, and can be used to create scenes based on actual cities, like the resulting image here. Next, let me introduce a new product that we recently released called the Shade3D BIM Sim Design Check option. This is an optional product that adds additional features to Shade3D the professional version of Shade3D. With this option, you can load IFC files, the standard file format used worldwide in the architecture and construction industry, and also performs checks on BIM sim designs. As a side note, SIM stands for Construction Information Modeling and is basically BIM for construction. So in order to turn project contracts involving the use of BIM sim models into official documents while making sure standards are met, the Japanese Ministry of Land, Infrastructure, Transport, and Tourism in Japan has been establishing standards that BIM sim models must meet in order for them to be published in official documents. And in particular, they are making guidelines for performing checks on BIM sim models built in the deliverables based on contracted projects so that design checks can be performed appropriately based on these guidelines. And hence, more projects now require design checks that conform to these guidelines. So first, the ability to import and export IFC files. This function allows IFC files exported from Forumate's design tools to be imported into Shade3D. And attribute information are displayed in the window where all other information saved in an IFC file is displayed normally. The text information in the IFC file can be edited and overwritten over the same IFC file. And as for IFC schemas, both IFC 2x3 and 4x1 are supported. So, the tool automatically performs collision check, and collision check is complete. A list of members are causing collision with a reinforcement rebar is displayed. And these are just additional uses for the BIM sim design check tool. So one new important feature for Mac users is that we now support Shade3D for Mac users with Apple Silicon. And therefore, in order to maximize the performance, it's necessary to take measures on the application side since the actual hardware has changed entirely. So the new version of Shade3D will be able to run natively on Mac with Apple Silicon, compared to the current version that can still run on such operating systems, but has to run through virtualized middleware. The performance of the new version will be far greater, and in particular, the rendering speed will increase significantly. So this is a video of Shade3D running on Mac with Apple Silicon, and the current version of 3D on the left side has Intel displayed as the type, and this version can run via virtualized middleware. And the current version runs via middleware. It can only use up to 4 processor cores, even though there are 8 processor cores embedded into the Mac hardware. However, the new version of 3D can run natively on Mac using all of the 8 processor cores. And when you open the activity monitor during rendering, you can see that all processor cores are active, which goes to show that the new version of Shade3D makes most use of the powerful performance of Apple Silicon that Apple Silicon has to offer. This update is compatible with Mac with Apple Silicon, once again. We also have a block programming UI tool. This is a simple educational programming tool that's very easy to learn, and it's a function that is useful to introduce to children who are learning how to program. So, some future prospects for Shade3D, as you can see here, are some expanded Python scripting capabilities, enhanced DFX output function, C++ plugin, and these are all due to be developed and updated in this year. And in the summertime, we're hoping to also enhance modeling capabilities, support new animation features, and support for advanced PBR materials, linear support, etc. And also continue updating the BIMSIM design verification tool and the block programming tool. And we're also preparing a website where you can purchase the material data, and some of the data will be available for Shade3D users in the actual application as well. So finishing off, I want to talk a little bit about our other flagship software, UC WinRoad, and how you can integrate that with the Shade3D software. So first off, UC WinRoad is a 3D real-time virtual reality software, and it's used as an advanced software that can create large 3D space with even any simple PC operation to perform various real-time simulations. So how it functions is it can generate topography, and you can see here that it can generate large-scale to precise topography. It's extremely good at road generation, hence the name UC WinRoad. And you can create complex road structures with just really simple clicks and minor parameter changes. And lastly, to add on to the final touch, the environmental expression, so like a change in season, in time, and the weather, the lighting can also be generated all within the same software. These are the common applications that our users have used this software for: town creation, landscaping, road and intersection creation, traffic simulations, hazard simulations, construction simulations, earthquake and disaster simulations, and planning, especially since, for example, in Japan, we have a lot of natural disasters that occur. So this is really useful for governments and companies who are looking to research and gain more insight for their product and services in this area. And we have a full lineup of different types of hardware simulator, from anywhere from 0 degrees of freedom all the way up to 8 degrees of freedom here. And if you have any questions or inquiries about our software, please feel free to let us know and send us a question or an email, and we'll be more than happy to help you out with any questions or customization needs that you might have. So how can Shade3D be linked with this UC WinRoad software? Right here is a full diagram of all the software options that we offer here at Forum 8, all the way from engineering tools to modeling CAD tools to office products and web cloud services. Today, we're going to be focusing on Shade3D, which is mostly used for modeling. And you can see that it's related and connected to UC Winroad in that you can input and export FBX and 3ds formats. So say you're creating a vehicle, you're like designing a model car. What you can do is actually use the 3ds FBX or Collada file type to export that into UC Winroad for simulation. And then you can see how your vehicle would look in this environment and change the immediate reflection of time, weather, etc. And vice versa. If you were starting out in UC Winroad and you wanted to maybe brush up a little on a certain vehicle or a certain building in that environment, you can export that into Shade3D using 3ds. And then you can change the material settings and do rendering to make a much sharper and image with a higher resolution for your needs. So we are right on time for the first 30 minutes of the presentation. So from now until 2:20, how about 2:20? Let's say that. We'll take a 10-minute break. If you have any questions, feel free to ask us or put that into the chat, and me and my colleagues will do our best to try to answer your questions. And while you're at it, please, we do really appreciate to get feedback for all of our seminars. So this is the QR code. Please take a look at the survey. It'll only take a few short minutes, and it will be really helpful for us to improve our future webinars. So now we're going to take a 10-minute break. All right. It is 2:20. So let's get back to our operation parts. So I believe my colleagues have sent all the attendees the actual trial or one-day seminar use licenses for the Shade3D software, as well as a guidebook. So while I am actually operating the software itself, please feel free to follow along using the application on your computer. And if you get lost, please also refer back to the guidebook. Then without further ado, I'm going to start the actual operation. So please take a look over at my screen. Sorry, can you guys hear all right? What can you hear if you cannot hear anything? Sorry, let me just take a sorry. I'm going to go back to the beginning.
Hear the audio at all.
Even after you try to raise your volume to max?
Yeah, even after.
Okay.
That's what she said.
All right. Then let me restart. And we'll try it one more time. So here is the GPU ray tracing example that I talked about in the version 22 update right now. As you can see, first, this is the past traditional rendering using the GPU ray tracing, and you can see that it's very blurry and it takes a long time to render the building image. So I'm going to stop the traditional rendering through GPU and do the GPU ray tracing. Works. As you can see, it was finished in literally just 1 second, and that is how fast it is, and the difference between the traditional ray tracing and the newer GPU ray tracing function. So now let's open up the Shade3D software. You can see in the top left corner, there's 2 different modes, CG and CAD modes. To the right, you can see the control bars and tools and options. You can see there are 4 pane windows that you can work in. And you can drag and click on the different window that you want to work on and change the ratio of the actual windows that you want to work in. A really strong feature of Shade3D is that you can open multiple files at the same time without having to reopen the software multiple times, which will save you a lot more processing and work time. So it's really convenient for people working with many models and files. And in the toolboxes are some common tools that we often use when we're working with Shade3D. So now I'm going to go back and choose the CG mode and go to the Create Sample Object, choose the square over here, and I'm going to drag it up and then draw it in the window. And you can see that this prism is created. And in the left bottom are the tool parameters. And you can see you can actually adjust this as needed. So let me apply first. And you can see a symbol model of this box has been created. If you click on the middle roller of your cursor, you can see that you can actually basically change the scaling and look at the box from different angles. And you can change the scale of your box by dragging on the different axes as well. In the top right of one of these windows, you can see different icons. If you click on the cross, you can see that your model can be seen at different camera perspectives. The next one is the rotate button, where you can rotate the model and look at your model by rotating it. And if you use that same button in the other windows, you change the positioning of your model. In the third button here is a zoom in and zoom out button. To the left, there's a target icon. And if you go to the leftmost bar here, you can change the actual view from top to right to meta camera. If your model is out of sight from the window panes, you can find your model again by pressing on the target button that I just talked about. And you'll go back and your model will be centered again. The last button on the right, it's a display button for wireframe and shading and texture to view your model in different shading and wireframe and textures. So in different windows, you can use different displays, options, and view your model through different displays. Since you also have the off software downloaded, please play around with it on your computer as well. Now let's continue on. You can see that if I click on the box, there's a multi-purpose axis. You can see in this drag down tool here, there's different types of options to change this plane from universal to translate. For example, in the translate function, the model can move in the XY planes, left, right, up, down. And then you can see the small light triangle. When you click on that one, you can rotate the model in a according to the actual axis of that triangle. For scale, instead of moving the actual model itself, you can click on the squares, and it's actually changing the ratio and scaling of the actual model that, and it's changing it in the direction that you're dragging it at. And it can also change the entire XYZ axis dimensions if you're pressing on the center cube. When you choose the rotate option, you can see 3 circles, and they'll rotate according to the 3 different plane axes of the 3 circles. So if you feel like you made a mistake, try to click Ctrl+Z and it will cancel the command that you just clicked or selected. So let's continue. Now, let's make a new untitled file. As you can see, there are 2 files here lined up. We're going to try create the create option under toolbox. Go into primitive, surface. In primitive, please choose the sphere, and then we're going to draw it onto the top view and press apply. Go into surface, draw another ball on the top view window, and then go into mesh, and then please choose the same shape again and press apply. You can see on the right side, there's a browser. And in the browser, you can see the individual shapes specified attributes. So what we can do to edit is go into modify here on the top left. And then you can see the axes of the plane appear, and you can drag the arrows to change the shape of the sphere that we created. So this is a really basic editing feature. So if you don't have any detailed changes that you need to make, you can choose this one to modify your sphere. And then next, if we go into the same modify and go onto the surface sphere, you can see when you're dragging it, you're not just changing the shape, but you're actually changing the shape at a very specific point of that sphere. And if you go into the third mesh sphere, please choose that one in the browser and then go into modify again. And then this time, instead of vertex, we're going to choose face. So now we can either edit the vertex or use an edge to change the shape, or use the actual like face. So when you choose face, you can see that you're moving a wider surface of the actual sphere. So please try it out on your computer as well. So next, let's go into the sample shape modeling of the robot. Let's create a new file again. And please open up the preferences in your edit Dropbox and make sure that the up axis is chosen as Y and not Z. Please choose Y as the up axis. Press apply and go into CAD. Go into the CAD mode. So now in the split view, let's pick the fan here under the toolbox. We're going to draw this fan while press down Shift using your keyboard. Please draw this fan and then drag it up to the turning to the left so that you can see there's a fan. And then in the tool parameters, please change the coordinates as needed as according to the guidebook. Here, the endpoints are 300 and 1400, and then press apply. So these are the specific parameters, correct coordinates that that you should input in. Okay, so now let's continue. Next, let's choose the rotate. Please press your left cursor and drag down. And then you can see you've created a dome. And then again, please change the coordinates in the tour parameters according to the guidebook. And then press apply. Here are the coordinates again for your reference if you don't find it in the guidebook. Okay, now let's continue. Next, let's pick the cylinder in the Create toolbox. In the top view, please drag the shape. And then in the front view, please press Shift and then drag it up. Drag it up and then change the parameters again. And here are the parameters. So let's continue. Now we're going to choose a sphere. And then in the front view, we're going to make an eye, the eyes of the robot. Change the parameters of that shape for the eye. And here are the coordinates again. If you go into the browser, you can find the eye that you just created. And to make things less confusing, we're going to name that specific shape eye. And then let's continue. Take a cylinder. In the top view, draw the cylinder and then drag it up. And then change the parameters again. And then press apply. And here are the data. Now let's continue. Next, the body. Let's pick the cube. Draw the cube on the top view and then in the front view again, press Shift and drag up again. And then change the parameters again. And here are the data parameters again. All right, let's continue. Let's edit the body now. Pick the modify edge, press shift, and then we're going to pick the face. Go into the toolbox and pick chamfer, and then please put in 100 in the tool parameters. And you can see that the two edges here have been cut. And we're going to apply that. And the body would be created here. Okay, now let's continue to create the rest of the robot. Pick the circle again, go into the top view, drag the shape outwards, and then change the tool parameters for this shape again. Press apply. Okay, and please try it out on your side. Now we're going to pick the Norbs curve on the browser and then press Ctrl+C to copy that. Paste that and make sure we have 3 other Norbs curves created. So there are in total 4 of those created. Okay, let's pick the second one. Go into the aggregate menu in the info. Let's change the positioning and size according to the guidebook's coordinates and the data given. And also we're going to modify the third Norbs curve according to the data given in the guidebook. And then likewise for the fourth Norbs curve, please also pick that one and then change the data. Now, let's press Control and pick all 4 of the Norbs curves, and you can see all 4 of them have been created when you look through the meta camera perspective. Let's go into Create, go into Loft, press it, and there's a shape that has been generated, but this is not the one that we are looking for. So let's go into Loft and then pick Ruled. And you can see the shape has changed to the one that we actually want. All right, and please try this out on your side as well. Okay, now let's continue. Let's pick the ball again. In the front view, let's draw the ball and then change the tool parameters again. And here are the data parameters. and then press apply. Now we're going to try to compress this specific shape. So press the Z button. Sorry, just press the little square and drag down. And you can see that the ball has been molded a little. And then we're going to change the y-axis to 0.75. Apply that. Next, let's make the arms. Pick the capsule. In the front view, press down, press Shift, and drag down. Press Shift and then drag left and right. And then you can see the arm has been created. Let's make the arm more precise by changing the data. Please pick the select inside and press that box and then press apply. Next, we're going to make the hand. We're going to pick the torus shape. And then in the front view, please drag it. And then drag it a second time. And then change the parameters. And then you can see the parameters here. Let's continue. Let's pick the cube. And then in the top view, let's draw the cube. And then in the front view, press Shift, drag up, and then after that, change the parameters again. And then press apply. Next, we're going to pick the last two NORBS surface. And then we're going to do a Boolean operation difference. So for the last two objects that we created, we're going to drag that under the Boolean operation. And you can see after the Boolean operation, the shape is now invisible. So we have only created half of this robot. We're going to do a mirror image and make the other half. First, we're going to pick the shoulder, the arm, and the hand, and go into part with selected shapes. Get that one under the tree. And then you can see all of the parts that you have created has been selected and put into the tree under the part section. Now, I'll give you some time to try it out on your end as well. Okay, now let's continue. Let's choose the part that we just made. Press Shift and then choose the eye as well. And then we're going to do a mirror. As you can see, the eye and the arms part are all chosen. The center is a little off, so we're going to try and edit that. Press the center of the body. Drag the center part to the middle of the body, towards the middle of the body. Press the Z button and then on your keyboard, and then drag from right to left by clicking on the square. And then you can see that you have copied the right side or the left side of the robot from its perspective to the right side of its body. And then you're going to change the coordinates to -1. Press apply, and then you can see the symmetrical image has been generated for this robot model. Okay, now I'll give you some time to try it out. Okay, now we have generated the first part of the operation. We are a little ahead of the time, so please try and follow up to this part of the model if you haven't had time to follow up and catch up. We will take another 10 minutes break. I'll see you guys back at 3:10 p.m. in Japan time. And please calculate it according to your time, accordingly to your time zone. And I'll see you back in about 10 minutes to go on to the second half of the operation section of the webinar. Thank you.